y equals negative sign of pi over 2x minus 3 pi over 2 minus 3. Let's start by labeling our values. And a is 1. Again, it's the number in front of the sign. It's not the negative, because the negative is going to reflect our graph over the x-axis. Our b is the coefficient, the number in front of the x, which is pi over 2. Our c is going to be 3 pi over 2. And our d is 3. I don't think that it's going to make any difference if you write minus 3 or positive 3, because what we know from here is that since it is minus, this is going to be down 3. Our amplitude is 1. To figure out our period here, just in terms of space, to use my space up here, we're going to take 2 pi divided by pi over 2, which is the same thing as 2 pi times 2 over pi. And what we find here is that we get 4 pi divided by pi, which is really 4. And let's put that on our graph right now. 1, 2, 3, 4. We actually also have a phase shift in this problem. Remember that the phase shift is determined. Sorry about that, I can't get that in there. Shift. Phase shift is going to be determined by c over b. So this is going to be 3 pi over 2 divided by pi over 2, which is really 3 pi over 2 times 2 over pi. And what we get is we get 6 pi over 2 pi, which is going to be a value of 3. And because it's minus, we're going to go right 3. Still a sine or a cosine function, so our domain is going to be all real numbers. And now let's mark up our graph a little bit so that we can actually draw the picture. And if we go up here and we look at our highlighter here, we've got a couple of things that we can put in. Starting with the fact that we're going to go down 3. So let's put a value in here at down 3. But we're also going to go right 3. Here. And then where I'm going to be starting as I draw my picture is I'm going to be starting at that intersection of that aqua highlighter line, or origin, so to speak. Don't forget, and maybe I'm speaking more to myself than to you, that we have to reflect the graph. But when we start with sine, we're going to start at 0. So I'm thinking of the intersection of these two values to be the origin, so to speak, and then 1, 2, 3, 4. So there's our sine. We need to reflect this graph over the x-axis. So what happens here is, instead of going up 1 now, we're going to go down 1. We're reflecting. And then we're going to go up 1. And what we have here is 1 period. But I can also, to check it on my graph, I like to carry it back to the origin. So I'm going to start here on my next period. I don't have the whole period. But when we type this into the calculator, and I already have it typed into the calculator, I don't have the window in there. But if I go to y equals, I have the function typed in. And then what I want to do on the window is I want to start at 0. And then let's see where we're going, because it's 1, 2, 3, 4, 5, 6, 7 here is where we finished. It looks like one more check. 1, 2, 3, 4, 5, 6, 7. So this is 8 right here. I'm going to go to 7. going to be 0 to 7, increments of 1, and then our graph is still negative 5 to 5. And does that match what we have here? Well, 1, 2, 3, 4 down, yep. Then we went up, and we went down, and we went up. So yes, we checked it. Our range here, we might as well finish this over here. Our range is from negative 4. Remember, you start from low to high. Negative 4 to 2. And then we can keep copying the pattern now of our graph. Easy enough to go from one end of the graph to the other. Number 4. Y equals 2 cosine of pi x plus pi over 2 minus 1. And let's start by filling in our values here. Our amplitude is 2. B is pi, the value in front of x. C is whatever we're adding or subtracting inside our parentheses. And then D is 1. If you prefer to write negative 1, that's fine. Because ultimately what's happening with that 1 is that it's adding 1. Our amplitude is 2. Our period, well, our period is 2 pi divided by pi, which is 2. Our phase shift, let me just abbreviate for PS for phase shift, is determined by C divided by B, so it's pi over 2 divided by pi, which equals pi over 2 times 1 over pi, which is 1/2 when we multiply. And in fact, this one is plus, so plus means that we're going to go left 1/2. By the way, we do not have a reflection. There's no negative on the 2 out front of the function. There's no negative on the pi inside the function. And this is still a sine or cosine graph. So our domain is this. Eventually, for our range, we'll have something in between there. And when we come over here and look at our picture for a minute and label it with the period, 1, 2, 3, 4, there's the 2. So here's 1, which means that we can get our 1/2 in. 1/2 is 1 mark on the graph, but we're going left. So we're going to go there. We also have a down 1. So we're going to go here. And now we've got the graph labeled, and we can draw the picture. Cosine. Cosine of 0 is 1. And then we've got a 2 in front of it, so 1 times 2 is 2. And we're going to start where this highlighted lines intersect. So we're going to go at 1. That's 2 spaces above the new x-axis, so to speak. And then 1, 2, 3, 4, we're going to finish here. We went 2 spaces above, so we're going to go 2 spaces below. And then our middle values are here. Did we reflect? We didn't reflect, so I think I'm good here. So there's 1 period. And let's continue drawing periods. I'll let you check it on the calculator. And all that we're doing is we're copying the pattern. So if you wanted to, in terms of your calculator, this is 1, 2, 3, 4. You could go from -4 to +4 and check your graph on the calculator. We went from -3 to +1. Our low point on the graph is there and our high point is at 1.